I will begin by creating a C++ application for MontaVista Linux Professional Edition, including the appropriate toolchain for a virtual environment. MontaVista does the integration of many variations of Linux support packages and toolchains for our customers so they can focus on what's important. At this point, I will import a file that has some questionable code. The more code, the more difficult it becomes tracking down any particular sources of memory leaks and then prioritizing them. DevRocket Memory Leak Detection provides a list of those leaks and which ones consume the most memory. When a debugging session is launched, a connection is established to the remote system, and in this case, my virtual target, and the specified program is run under the control of the open source tool mPatrol, with which it is dynamic. With the default options set for mPatrol, we collect information on memory allocations, free events, a backtrace for each allocation and free event, total amount of memory each function and its children allocate, amount of unfreed memory at program termination, and which functions allocated that memory. And then we also look at call sites in the same function that are. This wizard steps me through creating, managing, and running configurations. I simply connect to my target and set up a new, and then choose a remote binary path or where on my target my project will reside. The memory leak detection view opens automatically when the debugging session completes, and it is divided into the call graph, which provides a tree view of application functions and their children, call from, which displays a backtrace of allocations for the functions selected in the call graph table, and errors, which lists all errors and warnings generated during the debugging session. As we can see here, main is calling this first function 2 times. Notice here we created more bytes than we freed up. Under total bytes is 404. However, freed bytes is only 400. Let's double click on the function to take us directly to the code. I could delete the comments here and then fix the issue, but let's move forward. Digging in deeper here, we can see the allocation and deallocation functions that were called within that selected function I had in the call graph. Under type, you can see that I allocated memory, I freed it up, I have a matching pair, however I allocated it again and forgot to free it up. And then finally within DevRocket we can backtrace our selected function. And double clicking on it takes us directly to the code so we can make corrections.